Okay, today we are going to talk about bisectors of triangles. We're going to start with the perpendicular bisector theorem, okay? If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And the converse of the perpendicular bisector theorem says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So, as you can see in this picture, we have FK is a perpendicular, which means it's a 90-degree angle, bisector of GM. So these two segments are the same. So any point that is on this perpendicular bisector, like point F, is going to be the same distance to each of the endpoints of this segment. So the distance from F to G will be the same as the distance from F to M. And if you know that a point is equidistant from both endpoints of the segment, you know that it has to be on this perpendicular bisector. So we'll look at some example problems of that in just a moment. We got a couple of other bisector theorems. This is the angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. And the converse of the angle bisector theorem says if a point is in the interior of an angle, if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. So if you have an angle bisector, and if you have a point on it, and it's the same distance to each of the sides of the angle, and the converse is that if a point is inside the angle and it's equidistant from the sides of the angle, then it's on the angle bisector of the angle. All right, we're going to look at some example problems to see how this plays out. I want to tell you that there's a lot of problems in this particular activity that are not drawn to scale, so we're going to go based off of the markings and not what the drawings appear to be. So it says to find each measure. So this point E is equidistant to the sides of the angle. That means that it lies on the angle bisector. This has to be the angle bisector. Angle bisector, again, we learned that earlier this year, means that it splits the angle into two equal angles. So they want us to find the measure of angle ABE. Since this is an angle bisector, the measure of angle ABE would have to be 43 degrees. Okay, now let's look at this one. Again, point A is equidistant from the sides of the angle. That means that it falls on the angle bisector. This segment AB is the angle bisector. So, given that we know ABF is 47 degrees, they want us to find YBA, angle YBA, has to be the same. It has to also be 47 degrees. Okay. The next one here, MK. We're supposed to find the length of segment MK. Before we can find the length of segment MK, we're going to have to find X. So we're going to have to write an equation to solve for X. Notice this segment from V to K is an angle bisector. It's marked with the congruent angles here. And these segments are perpendicular to the sides of the angle. They meet at the same point, so they have to be equal to each other. So we are going to write an equation, 2x plus 1 equals 3x minus 8. And we're going to solve for x, getting the x by itself. I'm going to subtract 2x from both sides to get the x's together. So 1 equals 1x, or just x, minus 8. And then I'm going to add 8 to both sides. So 1 plus 8 equals 9. So x equals 9. But this is not the answer to the problem because they want me to find how long it is from M to K. MK is equal to 2x plus 1. We now know that x is 9, so we're going to substitute 9 in where the x is. So mk equals 2 times 9 plus 1. And that means 18 plus 1 more gives us 19. All right. Number 4 is quite similar. It says that point L is equidistant from the sides of the angle. And both of those segments are congruent. That means WL has to be the angle bisector. So these two angles must be congruent to each other. They want us to find the angle EWL. So before we can do that, we're going to have to solve for x. Since these are the same, we can write an equation. 7x plus 5 equals 3x plus 21. Now we're going to solve for x, so I'm going to subtract 3x from both sides of the equation. 7x minus 3x is 4x, plus 5 equals 21. Subtract 5 from both sides of the equation, so 4x equals 16. Then divide by 4 on both sides, x equals 4. And now we just need to substitute that in to find the measure of angle EWL. So that measurement will be 7x plus 5. We put in the 4 where the x is. So 7 times 4 is 28, plus 5 more equals 33. Okay, down here at the bottom, XW. We're supposed to find this length. Now, notice that this is the perpendicular bisector of this segment. This is another right angle, 5 and 5. These are equal length segments. So that means that the distance from any point on that perpendicular bisector to the endpoints of the segment should be the same. So if that's 7.5, XW should be 7.5 also. And on this one, again, we have a perpendicular line. This point E is equidistant to the endpoints of the segment. So this has to be the perpendicular bisector, which means if AB is 4.2, BF will also be 4.2. All right, moving right along. On the next problem, we have to solve for x. We have perpendicular angles here. This segment is a perpendicular bisector because point E to F is 63, E to D is also 63. So these two distances have to be the same. 5x minus 17 has to equal 3x plus 1. So we're going to subtract 3x on both sides. 5x minus 3x is 2x. Minus 17 equals 1. Add 17 to both sides of the equation. 2x equals 18. And then divide by 2 on both sides. X equals 9. And that's what they asked us to find here. On number 8, I'm going to skip number 8. Number 9, we have a perpendicular line. Point S is equidistant to the endpoints of the segment. That means this is a perpendicular bisector, and it means that these two segments, TU and UR, have to be congruent. So 2x plus 24 equals 5x minus 30. I'm going to subtract 2x from both sides. So 24 equals 3x minus 30. Now I'm going to add 30 to both sides. 54 equals 3x. And now to get the x by itself, divide by 3 on both sides. X is equal to 18. Oh, but that's not the answer to this problem because they asked us to find TU. So TU is 2x plus 24. Jump the gun there. 2 times 18 plus 24. So 2 times 18 makes 36. Add 24 more to that. That equals 60. So 60 is the length of TU. And that's the answer to the problem, not 18. This was a multi-step problem. We're going to skip number 10. And we're going to skip number 11. And we're going to go down here and do number 12. So on number 12, it shows that point M is equidistant to both sides of the angle. So that means that the segment YM is the angle bisector. They want us to find the measure of angle MYW, but before we can do that, we're going to have to solve for X. So since these two angles are equal, we can write an equation. 4x minus 1 has to equal 2x plus 5. And we'll subtract 2x from both sides to get our x's together. 4x take away 2x is 2x minus 1 equals 5. Add 1 to both sides to get the constants together. 2x equals 6. Divide by 2 on both sides. X equals 3. But that's not the answer because they want us to find the measure of angle MYW, which is 2x plus 5. So we're going to substitute the 3 in place of the x. 2 times 3 plus 5, which is 6 plus 5, which equals 11. So the measure of angle MYW is 11. All right. Now, here are the directions say in the next two problems. Determine whether there is enough information given in each diagram to find the value of x. Explain your reasoning. So let's look at number 32. They want us to find x. And this is an angle bisector. So it looks like it's probably 5, but the segments being equidistant to the endpoints of the angle mean that, to the sides of the angle, these have to be measured along a perpendicular. And they don't have any perpendicular marks here. So we're going to say not enough information it's missing the right angle marks. Without those right angle marks that I just drew onto the picture, you cannot say with certainty that x is equal to 5, even though it looks like it should be, because if one of these was just slightly off from the other, like at an 89 or a 91 degree angle, it would be longer or shorter than the other one because you don't know that it's measured at a perpendicular. Okay, let's look at number 34 here. It says we're supposed to find x. It looks like it might need to be 7, but we don't know that this is a perpendicular bisector. We know it's a bisector. It split this bottom side in half, but there's no right angle. So again, we're going to say not enough info. It's missing the right angle. If that right angle was there, then yes, that would be 7. But without it, it could be that one of these segments was slightly longer or shorter than the other if it was not a right angle, if it was very close to a 90 degree angle, but not quite. Okay, this next problem says segment BD is the perpendicular bisector, so we know this is a 90 degree angle, of segment AC, so we know these are the same. If that one's 4, this one is 4 over here. What is the perimeter of triangle ABC? Well, we can find the length of the side AC. That one's going to have to be 8 because it's 4 plus 4. But we can't find CB or AB until we know what X is. Since this is the perpendicular bisector of this segment, we know that point B falling on that perpendicular bisector must be equidistant to the endpoints of segment AC. So that means these two are equal. So we're going to set them equal to each other. 7x minus 9 equals 2x plus 1. And now we're going to solve for x. So subtract 2x, 5x minus 9 equals 1. Add 9, 5x equals 10. And then divide by 5, x is equal to 2. So if x equals 2, we can substitute that in here to find the length of this side. 2 times 2 plus 1 makes 4 plus 1, which is 5. And this one should be the exact same. You could sub it in if you want. 7 times 2 is 14, minus 9 is also 5, but you don't really have to because of the geometry we learned today. We already know that those need to be congruent segments because this point B is equidistant to the endpoints. Now look back at the question. It asked us to find what the perimeter of triangle ABC is. The way you find the perimeter is by adding up all three sides. So we go 8 plus 5 plus 5. Top side, left side, right side. That gives us the perimeter. So that's 10 plus 8 more is 18. So the perimeter is 18 for that triangle. All right, I hope that you have a great time doing your assignment. Please let me know if you need any help at all, and have an absolutely fabulous day. Bye for now.